So here we go. We are set. Does JC want to say hi to Morgan? No? All right. Sorry, Morgan. JC is not acknowledging your presence. That it is possible. So sometimes in my other classes, I embed prizes in the video. So I'll say, for example, that if you say the code word San Francisco, if you come back to class, you say San Francisco, then I'll give you, some type of prize. Just try to keep people honest to watching the videos. Sometimes it works, sometimes it doesn't. But my guess is that Morgan will not watch the video, but rather that she will go to JC and say, hey, what did I miss, kiddo? And being JC is such a kind-hearted person, will help on out. Okay, here we go. Zero product properties. So today we want to put together our factoring techniques to be able to solve polynomials. As you notice, this one says, what number do you square minus 2 times another number minus 15 to get 0? And so if people are not knowing what they're doing, here's something that they may attempt in this situation. They may say, well, I'm going to take x squared minus 2x, and I'm going to set it equal to 15. And then I'm going to factor out an x to get x minus 2 is 15. And I'm going to add 2 to both sides. I get x is 15 and x is 17. Okay? Looks good, right? But it's completely incorrect. If you put a 17 and a 15 in for x, you're not going to get the right result at all. The fact is that when you recognize that x is not to the first power, but rather to a higher degree, like 2 or 3 or 4, you have to change your techniques for how you're going to solve it. And what we like to implore is the zero product property. The zero product property says this. It says if A times B is equal to 0, then we know something's true. What do you know is true if A times B is equal to 0? If two numbers, their product is equal to 0, then one of those numbers has to be equal to 0, right? If A times B is 0, then A is 0 or B is 0. That has to be true, which you can't say that about any other number. So some people might say, well, if A times B is equal to 24, then one number must be 4 and one number must be 6. Is that the case? No, there's all sorts of other numbers that multiply 24, right? You got 8 and 3. You got 12 and 2. You've got 24 and, you got 24 and 1. Or you even have 48 and 1/2. Like there's an infinite number of numbers that multiply to 24. But if they multiply to 0, then we can say for sure that one of the two must be equal to 0. And that's why 0 is a very impressive number. So here we have it. Use the zero product property to solve the following equations. We have this thing equal to 0. So what do? We try to write it in factored form. Factoring means to write it as multiplication. So I could write it as x minus 5 times x plus 3 is equal to 0. So in the logic that we first set up, we would say this is A and this is B. So I'll set each of those equal to 0. X minus 5 is equal to 0 and x plus 3 is equal to 0. Add the 5 and we get 5. Subtract the 3 and we get negative 3. Those are my solutions. If you plug those in, it will work. The first step is to always set it equal to 0. So I have 6x squared minus x minus 5 is equal to 0. Remember, that's the type that is slightly more difficult to factor. But I'm pretty good at guessing and checking, so I'm going to set this up as 6x and x. Anybody know how this finishes off? Is it plus 5 and minus 1? Is it plus 1 and minus 5? What is it? It is plus 5 and minus 1. And here's how I can check. I check the inside, which is 5x. I check the outside, which is negative 6x. 5x and negative 6x, those do make a negative x in the middle. That is correct. So now I have to set each one equal to 0. 6x plus 5 is equal to 0, and x minus 1 is equal to 0. Add the 1 to both sides, I get x is equal to 1. But notice that for the other side, it's not as simple as just subtracting the 5. I have 6x is equal to negative 5, and then when I divide by 6, I have x is equal to negative 5 over 6. And there I have them. Notice that letter C is even to a higher degree. We have x to the third. The first rule of factoring is to do what? Take out the common factors. So we have x times 4x squared minus 1 is equal to 0. Notice here that I have the difference of two squares. So x times 2x minus 1 and 2x plus 1. Now I set all three of these equal to 0. X equals 0. 2x minus 1 is equal to 0. 2x plus 1 is equal to 0. You may notice that the first one is already solved. X is equal to 0. The second one, 2x equals 1, and divide by 2, x is 1/2. And for the third one, subtract 1, 2x is equal to negative 1. Divide by 2, x is equal to negative 1/2. What would you do for letter D? Raleigh says gather everything on both sides. He said it in a silent manner, which I fully respect. He's a quiet man. So we'll subtract the 2x squared over. We also have a minus x, and then I add the 2 over to the other side. So it's good to set it all equal to 0. Is there a common factor that you can take out? No. Is it the difference of squares? No. Is it a trinomial? No, there's 4 parts. If there's 4 parts, then it's often a grouping problem. So we're going to group this one. I don't want to put a parenthesis down in front of a subtraction sign, so I write it as plus minus. And then I put my parenthesis down. What can you factor out of the first part? X squared, and I'm left with x minus 2. What do you factor out of negative x plus 2? I'll factor out a negative 1. Notice how now they both have an x minus 2. That's the piece I can factor out. Have an x minus 2. I'm left with x squared minus 1. Am I done factoring? Nope. X minus 2 times, what is x squared minus 1 factor to? x plus 1, x minus 1. So you can see that the solutions here will be positive 2, negative 1, and positive 1. Now, some of those are tougher than others. I want you to try A, B, C, D on your own. These should be a little bit easier. Try A, B, C, D on your own. Okay, see what you can come up with. Try to factor those and find the solutions. Go. Okay, the first one should factor to x minus 6 times x plus 2. So your solutions are positive 6 and negative 2. Questions on the first one? Your second one factors to x minus 3 times x plus 3. So your solutions are positive 3 and negative 3. The second one you have to factor twice. What do you factor out first? The negative sign produces x squared plus 8x plus 7. And then that factors to x plus 7 times x plus 1. So your solutions are negative 7 and negative 1. The next one also has a common factor. You factor out the x. So you have a solution of x equals 0 and x equals 11. I would say that those are the basic examples. Common factor, factor a couple times, trinomial, difference two squares. Any questions on that before we flip over? Flip it over. So, you help me. What about letter E? Start with what? Yep, negative 2. You'd be left with a positive x squared plus 2x plus 1. Does x squared plus 2x plus 1 factor? Yep. Notice how x plus 1 happens twice. When that happens, we like to list the solution twice. So x equals negative 1 is a solution, and x equals negative 1 is a solution. It's a solution that happens twice. It's important in the long run as we learn how to graph these things and be able to understand their behavior a little bit better. What is going to be your approach to letter F? Factoring by grouping. I don't want to put a parenthesis in front of a negative sign, so I add the opposite. I'll put parentheses there and parentheses there. Whoop. Silly Mr. Gentz. First, I start by factoring x squared, and we are left with x plus 2. What do we factor out of the next set? Negative 4, left with x plus 2. They share a common factor of x plus 2. When you factor out the x plus 2, you're left with x squared minus 4. Am I done factoring? Nope. Yep, it's the difference of squares, x plus 2 times x plus 2 times x minus 2. You can see again that you have a factor that occurs twice. We list the solution twice. X is equal to negative 2, and positive 2. Now in this example, I'd like to show you the mistakes that people make. It's not a trinomial. We always start by factoring out the greatest common factor, which is going to be 2x. When you factor out 2x, you are left with 4x plus 3. Couple mistakes that occur here, okay? Look at this first one up above you. Notice how it had a negative 2 out front. But there's no x attached to it, is there? If it's just a constant, you don't have to worry about it. There's no solution attached to it, okay? But notice how there is an x here. So you have to account for that. So if you set 2x equal to 0 and you solve, as we divide both sides by 2, you still get x is equal to 0. So if there's an x on the outside, out on the front, you will always have 0 as a solution. It's not going to be 2. If you have just a negative 2 out there, you don't have a solution, okay? But if there's an x, you will have a solution of 0. Second mistake that people make is they look here and they say, well, x is going to be negative 3. They often just write the opposite sign of that constant. Well, that's not correct, because this 4 in front is going to change that result. If you have 4x plus 3 is equal to 0, we subtract the 3 to get 4x equal to negative 3. And then we divide by 4 to get x is equal to negative 3/4. So the answer is not negative 3, but rather negative 3/4. So those are mistakes that people make. You can always check your answer by plugging them back in. And it should make sense to you. If you plug in 0, you get 0. But for this one up here, if you plug in 0, you wouldn't get 0. You get negative 2. Last one. Start by factoring out what? We're going to factor out the negative. We don't like the negative. The negative makes us frustrated. We don't like negative numbers. We like to be positive. Right, JC? We're positive people. Uh-oh, now I got a trinomial with a number in front. So I'm going to go 2x and x. I know it ends up being 5, so is it a plus 5 and a plus 1, or is it a plus 1 and a plus 5? Plus 1 and plus 5. And hopefully by now you see that if you set this equal to 0, you end up with a negative 1/2. If you set that equal to 0, you end up with a negative 5. You don't have to worry about the negative at all. It has no bearing on the solution to the problem. How's that? Okay, if you could take out your homework, I do remember the first time I gave this homework lesson, I gave problems that were, they were too challenging. Let's just put it that way. So I'd like to look and see what I gave to you and make sure that I gave you the correct type of problems. And I very much like what I see. Yep, your worksheet is set to go. We will review on Monday and Tuesday. You will have a test on Wednesday.